This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.6. This is a four-part question, questions 9, 10, 11, and 12, and hopefully we'll be able to answer them all in this small amount of space. A ball is thrown horizontally from the top of a building 42 meters high. So we should know by now to get a little picture. I know this is 42 meters, and I know that it's thrown horizontally. The ball strikes the ground at a point 107 meters from the base of the building. So I know that it's going to move this way, 107 meters. The acceleration of gravity is 9.8. Find the time the ball is in motion. So I've got x world. I've got y world. X world, I have a displacement of 107 meters. I have a velocity that I don't know. I have a time that I don't know. I know my acceleration is 0, as it always is. In the y world, I know that I have a displacement of 42 meters down, so my displacement is going to be 42 meters negative. I know that my acceleration is negative 9.8 meters per second squared. I know, since it was thrown horizontally, that my initial velocity is 0 meters per second. And I'm looking for my time it takes. Now, I should know by now that I can take my equation y equals v0t plus 1/2 gt squared. If my initial velocity is 0, I rearrange this and I get that my time is the square root of 2y over g. So in this case, it would be the square root of twice negative 42 over negative 9.8. So that will give me my time, and that's going to be an important thing to know later on. So find the time of the ball is in motion. Great. That is the answer to question number 9. Question 10 says find the initial velocity of the ball. Well, if I have a time, that time is also in the x world. So my velocity of the ball, that's an x velocity. Since it's got 0 y velocity, that's all x. So really this question could say find the initial x velocity of the ball. Well, I know that my velocity is simply my displacement divided by my time. Since my displacement is 107 meters, I'm going to take that and divide by the time I got over here. So whatever this answer is, plug that in there, and that will give me my velocity for this question number 10. It's my displacement divided by my time, because whatever that velocity is stays the same, boom, boom, boom. But if I just think of horizontally, it's moving at this velocity for some amount of time to go 107 meters. So there is my answer to question number 10. Question number 11 says find the x component of its velocity just before it strikes the ground. So when this object comes and shoots off and falls down this way, when it gets here, it's going to have a velocity in the x direction, and the y velocity will go from 0 and get bigger and bigger and bigger and bigger, and it's going to have a velocity in the y direction as well. So what is this velocity in the x direction? Well, let's see. It fell for this amount of time, but wait a second. In the x world, there is no acceleration. So the initial velocity is the same as the final velocity, is the same as its velocity overall, and so at the end it's still going that velocity in the x direction. So the velocity in the x direction is just going to be this same velocity that it's traveling over here, that I got right above. So that is the x component of its velocity just before it strikes the ground. Now, so that's my third one. These two answers should be the same. Now it says find the y component of its velocity just before it strikes the ground. Well, my y velocity starts at 0, but after this much time, what is my new velocity? Well, my final velocity in the y direction is going to be my initial velocity plus my acceleration times my time, or this could be g, my acceleration g times time. So my final velocity in the y direction, my y component of the velocity, since the initial velocity was 0, is just going to be negative 9.8 times time, and there is my time. So when I plug this in here, I'm getting at 9.8 times time, and that will give me a final velocity in the y direction. And that should be negative because it's going down. So I've got a y component going down, I've got an x component going to the right. What this did not ask you, which it could ask you, sorry, that's an x. What it could ask you is what is the combined velocity, the final velocity. And then you would slide your y over here, get yourself a right triangle, and you'd probably want this angle and this hypotenuse to give you an a squared, b squared, c squared. So you could Pythagorize these together to get the net total velocity, because these are your components. That would be your monster.